Nice to meet you. I'm Father Chuptai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to explain reaction of the period 3 element with oxygen, with chlorine and with water for AS chemistry students. Let's get started. So reaction of period 3 elements. Number 1, we are going to see the reaction of period 3 element with oxygen. In case of oxygen, number 1, we have to heat. For example, in this case, you can see that sodium is being heated with oxygen. And when the sodium is allowed to react with oxygen, especially on this hot plate, then it is going to make sodium oxide. The next thing is, as I told you, all these period 3 elements are supposed to react with oxygen, but the condition is heat. Whenever you are going to heat these metal, they will burn exclusively, appreciably, and so on. First of all, as you have seen that sodium is going to react with oxygen and bright yellow flame is going to be observed over here. And what is the compound that is being formed? That is sodium oxide, Na2O. This is the compound that has been formed over here. So after burning of sodium, especially at high temperature, it is going to burn with a yellow flame and sodium oxide, solid ionic compound is supposed to be formed. In this case, oxidation state in the oxide, that is equal to +2 for sodium, -2 for oxygen, and for 1 sodium, answer is +1. So oxidation state of the metal is equal to +1. The next element is magnesium. When magnesium is allowed to burn with oxygen, it burns with a bright white flame, as you can see in this picture, in this video. So that is the basic, you can say, very much specific flame, that is a characteristic flame. Now the reaction between aluminum and oxygen is over here. When magnesium is allowed to burn with oxygen, it burns with a bright white flame and magnesium oxide is supposed to be formed. In this case, in case of magnesium oxide, it's a white solid again, and oxidation state is +2. So here, this element, metallic element, metal magnesium, is going to show +2 oxidation state. Now the next one, when aluminium is allowed to react with oxygen, but it must be in powdered form to react with oxygen. It is also going to burn with a white flame, but reaction is going to be the normal reaction. It's not a vigorous reaction. In case of magnesium, the reaction is also vigorous. In case of sodium, the reaction was also vigorous. But in case of aluminum, reaction is supposed to be the normal. And here is the formation of Al2O3. Aluminum oxide is supposed to be formed. And in this case, this aluminum is showing +3 oxidation state, and so on. Again, the color of this solid is white, that is being formed as a reaction of oxygen and aluminum. Next thing is silicon solid. When it is allowed to react with oxygen, it's a very, very slow reaction. And here is the silicon dioxide, SiO2. A typical oxide, a macromolecular solid, SiO2 is supposed to be formed. And in this case, this silicon is showing +4 oxidation state. So you have seen that basically oxidation state of the element, period 3 element, is gradually increasing in a plus digit as we are moving from left to right in the period. The next thing is when phosphorus is allowed to react with oxygen, this phosphorus burns again vigorously. This part is basically the non-metallic part. Now we are going to talk about the non-metals. So non-metals are once again from phosphorus, that is the first non-metal in this period 3 element. It is going to react with oxygen, and again it's going to burn vigorously as almost white flame, and this white solid is formed, that is P4O10. P4O10 is a white solid that is supposed to be formed over here, and oxygen state is equal to +5. So in this case, phosphorus is burning vigorously, and again white solid is supposed to be formed. Next one, sulfur. Sulfur is going to react with oxygen, but this time the flame of color is not white, it's blue. Blue flame is supposed to be observed, and it is burning gently. The first one non-metal in this sequence, in this period, was burning vigorously, but this one is going to burn gently. And first of all, SO2 gas, that is supposed to be a toxic fume, toxic gas, is formed. If you want to change this SO2 gas into SO3, then you will have to apply the procedure of contact process, and you will have to apply the pressure, you will have to provide 450 degrees Celsius temperature and catalyst, and so on. Next thing is this chlorine and argon, they are not supposed to react with oxygen directly, especially argon, and chlorine also do not react with oxygen. One of the basic reason is the high energy of activation. So these are the basic major main reactions with their equation, with their observation, how the period 3 elements are supposed to react with oxygen, especially at high temperature. Now come for the next one. Period 3 elements reaction with chlorine. How these period 3 elements are supposed to react with chlorine? Again, the conditions are pretty similar. We will have to heat each and every element in presence of plentiful supply of chlorine. Number 1, sodium. Sodium react with chlorine. It reacts vigorously as it is the more active element, the most active metallic element, you can say, in this period, and is going to show almost orange flame. And NaCl, a white solid compound, NaCl is supposed to be formed, and in this case sodium is also showing 1 plus oxidation state. This -1, here the +1. Because sodium is the member of group 1 element, then obviously it will show +1 oxidation state. Come toward the next one, that is magnesium. Magnesium metal also react vigorously with a white flame, with a white flame, and it's going to make magnesium chloride, MgCl2 solid. Again, it's a white solid, and here magnesium is showing +2 oxidation state, and it belongs to the group number 2, so +2 oxidation state. Aluminium in form of powder can react with Cl2. It's reacting normally, but at very high temperature, at a huge temperature, or at a very high temperature, you can say, the flame can be observed, that is again white flame. And here is the final compound, AlCl3. Initially this compound is formed, then it will change itself into Al2Cl6. Then again, if you are keep on heating, this compound is supposed to be formed, and here its oxidation state is equal to +3. Here once again there is a major basic thing, that AlCl3 is an ionic solid at room temperature when it is heated above 451 Kelvin. So initially, at the time of birth, you can say, aluminium chloride is supposed to be an ionic compound. When it is heated till 451 Kelvin, and then it sublimes, its vapors are going to change the nature of bonding. Al2Cl6, it's going to be a dimer. So 2 AlCl3 are meeting together, are going to mix together to make a single unit, that is Al2Cl6, and this is a covalent dimer, a covalent molecule that is having covalent bonds and 2 dative bonds. If you keep on heating these vapors, upon further heating, especially above 1100 Kelvin, then this dimer break down, and vapors of AlCl3, that is covalent compound, solid AlCl3 is supposed to be formed, and that is supposed to be or said to be a covalent molecule. Now the silicon, reaction of silicon, reaction of phosphorus with chlorine, and phosphorus with excessive chlorine, and so on. So when silicon is allowed to react, you need strong heating for the reaction of silicon with chlorine, not under the normal condition. White flame may be observed reaction, it's burned very slowly. SiCl4, that is a liquid, and here once again oxidation state is equal to +4. So SiCl4, this formula you will have to learn by heart, and its state symbol as well, its color as well. So it's a colorless liquid. Colorless liquid, SiCl4 is supposed to be formed. PCl3 is a liquid. Again, in next case, when phosphorus is allowed to react with chlorine, PCl3 of colorless liquid is supposed to be formed again with a white flame, but reaction is very, very slow, you can say. Same is the case if you are going to use excess Cl2, then PCl5, that is an off-white solid, that is not a liquid. It's an off-white solid and it is supposed to be formed over here. And in first reaction, the phosphorus is showing +3 oxidation state, but here this phosphorus is showing +5 oxidation state. And at the last, this argon is not supposed to react as it's a noble gas and it is already stable. So these are the basic reactions of period 3 element with chlorine. Another aspect, another thing, that is aluminium chloride is considered as a simple covalent molecule and it is going to have weak van der Waals forces. So, and the second thing, and one more thing, it can be hydrolyzed by water. So if any compound that is supposed to be hydrolyzed by water, it is said to be having a simple covalent molecule. Its structure will be simple and this molecule will be the covalent molecule. Simple covalent molecule. This would indicate that its structure is simple and it is having covalent bond in it. So if any compound that is showing hydrolysis with water, it will be number one, covalent molecule. It will not be ionic molecule or ionic compound, and it will not be the macromolecule. It will be simple covalent molecule. If you are going to do hydrolysis and it's showing hydrolysis, it is going to split into other compounds. I mean, if it is being hydrolyzed. Now, the period 3 elements react with water as well, and the reaction of water is over here. Only 2 major elements are supposed to react with water. Number 1, sodium. Sodium react very vigorously with the water. They catches fire, explode, float on the water, dissolve into the water, form alkaline solution, and there is formation of a colorless gas, that is hydrogen basically. So, and this is the chemical chain, chemical reaction. So sodium in this period 3 element, sodium is going to react vigorously with the cold water. It's a cold water, and with the cold water, it's going to catch fire, floating on the surface of water, making solution alkaline, making a hydrogen gas, that is the basic cause of fire. So that is the vigorous reaction, violent reaction. Number 2, magnesium react with the cold water very, very slowly. Too slow to observe. Very slow reaction. But yes, there is formation of hydroxide. Magnesium hydroxide is supposed to be formed and hydrogen gas is formed. But if you are using steam, this is not the cold water. It's a steam. As you have seen that the state symbol is gaseous, then reaction is going to be vigorous. So you need a higher temperature, and you are using higher temperature as you are going to react with the steam. So it means you are using already higher temperature, and there is formation of MgO, magnesium oxide, rather than hydroxide. Hydroxide is supposed to be formed when a metal is supposed to react with the cold water. When any metal that is reacting with the cold water, it will make hydroxide. Any metal, if it is reacting with the steam, if it is not reacting with the cold water, then usually there is the formation of oxide, just oxide, not the hydroxide, and in both cases, hydrogen gas is supposed to be formed. Only these 2 elements react appreciably with the water. Rest of the all period 3 elements do not react with the water, not with the, especially the cold water, and not effectively or appreciably even in case of steam. That's all about today. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with your friends. Thank you. Thank you very much. Have a nice day.